Sure. Well, thank you very much for having me on this webinar. It's really fun to come to these things. I hope that it's entertaining and maybe there'll be something interesting that you learn. And I'm happy to try and answer any questions that I can at the end. So let me just start by describing the topic here. So it's automation in the cloud and how we use Terraform here at Civo. And I'll just explain who I am. I work here as a principal at Civo, and my role is to work with the SRE team and to help build things in Kubernetes and design infrastructure, and to help our team to grow and to accomplish anything that might be blocking them. I also work as a lead for the CNCF on the technical side for app delivery, and look at a lot of open source projects and due diligence. And prior to this, I've worked at JP Morgan, Amex, Microsoft, and a bunch of other companies as well. So I like to think that I've had a really nice bit of exposure to a bunch of different technology in the landscape. So let's talk about what we're here to discuss today. I think before we do that, I also want to give a bit of context for people who weren't particularly familiar with who Civo is. And these were kind of the points that struck me when I was thinking about how I would quantify what Civo does as a cloud provider. And I'll just sort of go through them. But the things that are interesting here are that they are quite unique in the sense that a lot of these you can get at a hyperscaler, but we have a unique twist on a lot of them. And for example, we have multi-regional data centers, but we have a very cool aspect of zero-touch deployments where you can push a rack into a data center and there you go. We're also a cloud-native Kubernetes provider and integrated with things like the marketplace. And we have this community-focused roadmap, and we are able to deliver very quickly and to iterate on that. And so, sales pitchiness aside, I think it puts us in a unique position where, as you'll see through this talk, we've been able to build out our infrastructure delivery very quickly and to iterate on that in very interesting ways to help us accomplish our goals. So, why are we here? I want to talk about our experience with Terraform. Effectively, some of the kind of pitfalls that people can often fall into, and I don't want to use the word anti-pattern, but I would say there are some things you can do to help build a pit of success rather than a pit of doom. And I think that Terraform can often be quite daunting. And there are challenges when you're adopting it at a small company and you kind of go all in and it becomes a bit of a spaghetti before you know it. I also want to show how you can refocus some of that energy to go more towards DRY, and DRY stands for, it's an acronym for don't repeat yourself, and do not repeat yourself rather. And it helps to steer you true when you're writing configuration, not to keep duplicating it. And I'd like to talk a little bit about that and a bit about workspaces and how we can start to isolate and segment risk. And then also how we think about multiple regions as a real example, and then illustrate how you can apply some of these practices to your own projects. And there are two repositories that I'm going to work from as a demo. So if you want a demonstration of Terragrunt and Terraform, which are two of the tools we'll be talking about, then you can take it, and I've got links at the end of the webinar. You feel free to grab it and run it yourself. So I wanted to start by talking about the Civo ecosystem, just to give some context of some of the complexities and some of the idiosyncrasies of where we work. And I wanted to start with this image, which illustrates what one of our regional clusters looks like. So they're typically a 28 node cluster with 4 control plane nodes, and there's 2x Intel Gold, 20 CPU with sort of 3 of DRAM, and then you've got a 2 terabyte NVMe drive on that box. And those compute nodes are all homogeneous, and it's a sort of a hyper-converged setup. And this means that we have a really nice blank canvas to start from. And so these aren't virtualized, right? We're running our super clusters on hardware, on racks that we own that are open compute based. And they have a 100 gig networking backbone, and the tenant networks versus the supercluster networks are isolated at the L2 level, which is also really, really nice. So the hardware we get to deploy and to operate on is very solid, but this also means that we have to coordinate the way we deploy things, right? Because you want to build a networking layer, you want to then build out your CSI storage layer, you then want to deploy things like your observability, and then your applications, and then at that point, you might want to think about your tenant architecture. And I've already mentioned quite a lot of complex concepts, this idea that if you're any other cloud provider, they don't just let you run your networking or your pods with theirs, right? We have this tenant isolation. And the point where I'm getting to with Terraform in this is that in Terraform, we're able to express all this, but as you can imagine, the complexity is quite high and the duplication would be enormous per region, because if you've got several dozen TF files and TF-vars files and variables files and output files, that's a lot of pipeline that you need to build on a per region basis. Because the important thing here to remember is that it's not just a duplication in the project, it's also GitLab or Jenkins or whatever you might be using as your CI/CD replication at the pipeline level. You have to be calling these different folders and different file structures within Terraform. So to give you an example of where we had some challenges in the beginning, and I think I joined just before last KubeCon perhaps, this was a typical kind of configuration you might find at Civo or any other company where you have a bit of a mixed bag, right? You'll get a bit of object storage that might be, some buckets that are manually configured in a standalone main.tf with a storage.tf file, and someone will run that and deploy it to a nameless hyperscaler. You might also then get an Ansible repository to set up some of those nodes I just described, and then you'll get a Terraform repository that has a whole bunch of all the other stuff and all the glue. And in our particular example, we had an interesting idiosyncrasy where we would use Terraform to deploy an Ansible operator into the cluster, and that Ansible operator would then go on to deploy additional things. So we were losing a lot of the immutability and a lot of the determinism, because when you're deploying operators in that manner, they might fail further down, but the Terraform process, the apply, has completed. So it's a bit of a misrepresentation of the actual state of the cluster. So there are a lot of problems. And as you can see, I've illustrated here that you have to make large-scale changes. If you imagine in your typical best practices document, it shows QA, prod, dev as big folders that contain all of your either module references or your slices of deployments. The problem here is when you're doing that at this interregional level, the risk level is enormous if you're considering this through a single backend or a single repository. So again, to illustrate, we started thinking about, well, this is a real challenge, and what do the best practices say? And the best practices say, hey, this kind of model where your applications are in the same Terraform repository and they're all referencing the various modules in that repository, and therefore you would have an EMS folder, and you'd then put in your specific TF files in there. And of course, you then still have a main TF file in each operator, but they're isolated and you can deploy separately. The problem with this is it's a misnomer that this is actually an improvement, because you're just moving the complexity and you're actually creating individual replications of the backend in each one of these, which doesn't really help either. And the reason that doesn't help is that you're creating a tribalism between these folders, in that there is going to be, for example, if you're using separate workspaces in Terraform Cloud, you'll then have 4 different workspace keys in these backends. And so they're actually starting to drift. So the operators themselves, anything that holds them together is that they're using the modules folder. They're not actually sharing any kind of common configuration objects between them. And there's more than this. There's also the practical element of deployment. You then have to look at running erratic arguments in terms of my Terraform apply is going to be targeted against a specific TF file, which means that if you want permutations of that in your GitLab YAML, you're going to, or your Jenkins file, you'll have a lot of variations, or you need to then have a variable to control this. So again, I come back to the premise of you're just pushing the complexity elsewhere. You're not actually solving for the problem of replication of a lot of this code. So this is where I wanted to bring in a tool that I mentioned at the beginning called Terragrunt. And I think a lot of people are probably familiar with this, but if you're not, it's a tool that was developed by Gruntworks, and it's open source, it's freely available, and it's a thin wrapper around Terraform. What's really interesting about this is that it effectively contains all of the internal Terraform commands, but it allows reparser to run on your HCL files and to expand variables, to do injection, and to do a slew of other really important operations that can start to reduce the amount of duplication that's required. And so you can see in this initial picture here that they're displaying how between environments you can inject different variables rather than having to use an entire templated TFRs file. And I'll go on to show an example of why that's useful and how much further you can take this a little bit later. Another really important part of Terraform is this idea that we understand state, and state management is incredibly important. And with Terragrunt, it doesn't neglect that. You can manage state in a far superior way, in the sense that if you're using a bucket, you can use prefixes on that state in a really smart way based on your folder structure, rather than having to have these sort of either nations of folders that contain encapsulated. You can use a single bucket at the root level, and you can then have subsequent environmental or application folders that can have a slash on the prefix for their state. And so I think the message that I'm trying to convey here is that Terragrunt was a really attractive offering when we were trying to get away from this kind of chaos back here of thinking, well, how do we bring this all together? If we were to start from scratch, what should we be doing? Is it really this? Is this the best practice? Are we not just expanding our configuration in a continuous copy-pasting affair? Even if this operator has one tiny difference between it, like an image, we're still having to recreate it in a new environment. So another really important and really useful aspect of Terragrunt is that, as I mentioned, and I'm sorry that the picture here is a little bit gray, but you keep the back end dry. And that's a great term. I never thought I'd say in a webinar. But when you think of like your front end application and your back end application, both of these might be deployed under the same workspace, or they might be deployed using the same backend. So that could be a local Terraform TF state file, right? And rather than them both controlling that backend.tf inside their folders, they can share a common backend. Because in the Terragrunt HCL file, there is an ability to look for your parents and look for your parent directories, your parent directory files. And so you can share a common ancestor with these sub files, and it can stitch together a backend and inject it into the Terragrunt config. It's probably worth talking about how Terraform and Terragrunt work together at this point. And I'm afraid I don't have a slide for this one, so I'll just try and describe it as simply as I can. What Terragrunt does, and I'll show this in the demo later on, is that it actually checks out your Terraform repository with your. It checks it out locally into a hidden folder, and everything that it says it's going to do, it injects into that folder. So the backend I just mentioned will get injected into that folder, and then it will run a Terraform plan or apply on that folder. And so therefore, when I say keeping your backend dry is useful, that's because it means that it will check out the modules for the appropriate folder you're running, and it will inject that backend without you needing to replicate that behavior.
We do have a question by Sam regarding this. So they're asking, is this a lot like templating the Helm values files with a tool like Hemfile in the Kubernetes land?
There are definitely similarities with templating tools. I'd say one of the big differences is that it has built-in functions that go beyond simple templating, and it also has the ability to control the commands in Terraform. I actually got a couple of next slides that might help make this a bit clearer. But yes, I think fundamentally there is an element of templating. There is an element of being able to do dynamic interpolation. And also there's an element of being able to use the file structure as a way of managing your environments rather than having to duplicate them across the file structure for isolation.
Well, yeah, I believe that answers the question. Yeah.
Okay, so let's continue, and I'm hoping that I'll make it clear as well. Another thing that was really appealing to us at the beginning as well is that you could execute multiple modules at once. And this is really useful. If you've ever worked with Terraform, you'll know that that's a real big bind, is that you have to either sequence it in the CI/CD, or you have to have a consideration around how big your modules are, because you might want to wrap multiple bits of functionality. the nice thing about this is it lets you compartmentalize in the sense that I don't have to make the decision of, I want to have all my AWS stuff in one module because it takes so long. You can actually start to make considerations around slicing them on your risk appetite. For example, all my Civo Kubernetes or all my Route 53 stuff will be in a single module. And as we start to talk more about this in the talk, we'll start to highlight this idea of workspaces as well, because modules can be isolated to workspaces. And that means that we're, again, slicing the risk level up so that as we're deploying out into live infrastructure, the kind of the movement of change is so small that it also means that we can feel confident that we can run this in a continuous manner into production. And again, like a really important feature, and you'll see some of the syntax here on the right of Terragrunt, and it might look familiar because it's also HCL, is that you can run pre and post hooks, which is actually, for someone who's worked with Terraform a lot, it's amazing. And so in this particular example, you can see that it's not doing anything very advanced, but you can start to use it to do validation steps. And especially when you want to start bringing tools like into the mix, you can deploy out infrastructure and within Terragrunt, use it as your engine to then check that the infrastructure deployment matches what you anticipated. So there's a very powerful suite of tools that this wraps around Terraform. So how does it actually look? I've described a little bit earlier, and it might have been a bit confusing without really showing you this slide. But effectively, when you're working with Terragrunt and Terraform, you split your concerns up. Terraform is a catalog of your modules that defines the outcome of what you're building, right? So you define a networking module that has your networking components, and those networking components need inputs. With the correct inputs and an application of those inputs, you can produce an output, and that will be a, that might be a container networking interface, that might be an elastic load balancer. But the point is that the Terraform repository has no set variables. It is purely the resources, the outputs, and whatever defaults you want. However, the Terragrunt repository becomes a config repository. So you're isolating the concerns rather than, as we saw in one of the first slides, having to copy paste between QA, dev, and prod. We've now got a beautifully pristine Terraform repository, can have its own CI/CD for changes, Terra test, Terra lint can be run. And on the left here, it's pure config. So you can see that the way I've split this up is we have a QA environment, a prod environment. We have a bunch of these regional configs. Now, why this is interesting is these aren't things that I have to call, like with Terraform. I don't have to call these manually in my step. These will be picked up by Terragrunt, given the way that the Terragrunt HCL file is set up. It will read these and it will pull out the bits of config that are relevant for the particular context it's running in. And that probably sounds pretty crazy. So I'm going to try and show this in the demo in a moment, that it affords us an enormous amount of power that we can jump into an operator in this environment. It can go up a directory, it can understand what directory it's in, it can figure out the regional config for this particular deployment and apply that into the Terraform repository. On top of that, you can share common configuration, and through all this, they can share the same backend and modify the workspace name so that they're working within the same organization. And so I hope that the key takeaways that I've illustrated here are transparent, and that is that able to separate concerns. You're able to increase the amount of folks that can work within these repositories at any one time. You're able to reduce the risk profile by slicing your changes into smaller and smaller module sets. And you can also share your configuration so that you can keep not only your Terraform repository dry, but also your Terragrunt repository to a minimal amount of configuration.
A question on this we have gotten is that how do you version the modules independently if you are keeping multiple modules in the same repository?
Yeah, so this is a good question. So what you can do is, and that'll come, I'll talk about that as well. You've got a few choices. You can actually apply a typical branching strategy on here. You can pull references from a branch. You can have tagged releases of modules. So for example, if you operate off the main branch and you're performing a network, a sequence of network changes, you can create a branch for feature networking. You can tag off of that feature. And then within only the components that want to work on that networking tag, you can pull that tag in, because each one of these will reference this Terraform repository and have a path on the ref, and then you can apply a SHA that you look up from. And I'll go to explain this a little more, but it's very flexible. You also have the ability to use local path. So if you decide that you're working on something that's too inhospitable to go into main branch on Terraform, you can use something called Terragrunt source, which allows you on your local machine to do a relative path lookup of a module and test that out. And so actually for productivity, this is light speed compared to some of the way that we've been working in Terraform. It means that I could apply a potentially dangerous change in a staging environment from my local machine or from a branch, but then the next time somebody runs Terragrunt apply, it overwrites that back to the common state. So yeah, it's a good point, and it's a very flexible way of doing it. You can use tags, you can use branch head, and you can use direct commit SHAs. And I'll show you later on some of the strategies that we use. Okay. Cool. So I think I'm going to take us to a little demo now, because that's always the most fun. So let's open up and have a look at what we got. Now, before we go any further, I need Kunal to tell me if my screen is too small, because there's nothing as bad as going through all of this and the screen being
I think it looks good, but if anyone of the audience they feel like we could increase the size, do let us know in the chat. Thank you.
Yeah, I'll be happy to zoom in if it's too small. But we'll be spending most of the time in VS Code, so let's get started. So there are two repositories. I've made them both available in GitHub, and I've got the links at the end. We have our Terraform configuration repository, and we have, Terragrunt configuration repository, and we have our Terraform module catalog. So let's start by looking at what the module catalog might look like. I've built a very, very simple example. This simple example has, let's increase that, has only one root folder called Civo, and it has a folder inside of that called eventually, like Civo IaaS, Civo load balancers, Civo storage, etc. Inside of Kubernetes, I've got a basic module structure. Now, if you run Terraform lint, that would probably fail because I haven't got an outputs.tf, even if it's empty. But it is a compliant module in that in the module root, you would define your providers. And you can inject these with Terraform as well. If you want to see that later, I'll show you. But in this particular main.tf, I've injected, I've added the module providers, and I've got a required version on the providers, but I don't have a backend defined, right? There's no backend defining the state management. You can see that we've got Helm defined here, though that is for future use. The most important one here is that we have the Kubernetes provider, and we're using Civo provider as well. We've also got a variables file, which has a few basic defaults, nothing too earth-moving here. But this is just so that you could potentially check this locally by adding a quick backend TF and making sure it works. It's also nice for the next person that comes along. If you haven't got a default, or you could put a description in, just so that they can see what this is supposed to be. So in this particular scenario, the thing that I haven't defaulted is token. And then the final piece is the actual resource. So we have a Civo Kubernetes cluster. That cluster has a data type that comes out of it. And it also has a Civo instance size that's used. So this Civo instance size comes from the Civo provider, sorry, the same as the data type. And these are used to inform the cluster. So it's pretty straightforward. It's a very simple module. And you could think about companioning with other services, buckets. And so that's what this looks like. It's really, really straightforward. So what I've set up in the left terminal, I'll open in VS Code as well, is Terragrunt. So let's start at the top. It's a pretty straightforward module. Repo. You have a bit of a difference though. We've got two folders, and these are representative of environments, right? This might be for you, EU West 1, 2, 3, 4, etc. The thing you'll notice is we have some different files here. So firstly, we have a terraform_config.htcl. You can name this whatever you want, by the way. This is just from an illustrative example. In here, you can see we have a locals set. Now, this is the remote tag version. Now, to that question a moment ago about how you can pin it to tags and to branches and to release multiple module versions, this is a simplified version. So what this actually aligns to is if I go to Terraform module catalog and we click on my tags, you can see that I've cut a tag here. And this is really nice, especially when you're working in a CI/CD fashion, that it can use a known tag of what's good rather than just head, right, which is a slightly dangerous proposition. So the tag is what we've set Terragrunt to use. And we'll come back to that in a moment. The other thing in here, which is where the exciting part starts, is the Terragrunt syntax. And so I'll walk through how this works. At the top, the locals file is where we are pulling things in from folders, from various files to read them into variables. This one here says basically, get me my environment config from this file, and from that file, get me my environment. And this one says, from your environment in your bash terminal, get me my workspace token. So we don't have to set any passwords. We can keep them all private and hidden and completely out of the context. And we also don't need to pass that annoying tf-vars flag every time we run it, which is great. But the really interesting part is this. This is a generator step. And what this allows you to do is it dynamically injects into your code as you run it, a new file. So in this case, I'm injecting dynamically a new Terraform backend. And that backend is connecting to my personal organization. And it is injecting the token and it's connecting to the workspace. So whatever the connected local environment is, it gets linked up as the workspace. And this is pretty cool. But there are probably a few questions to those of you who are reading this stuff, like where does that live? And you can see that's not the same file directory as this. It's because of the way that Terragrunt works is it effectively incorporates all of the Terragrunt files into as include files. So if I go 2 or 3 levels deep, this file will become included into the base level, to the current directory, and therefore it will be running from the current directory back up to the root. And so as it finds it on its way, it will see that regional config is in NYC1 and London 1. And this comes back to what I was saying a moment ago about the power of having the ability to identify where it is, pull out its own regional config, and then use that. And so London 1 and New York, the only difference between their regional config is that they have a different environment name. In the future, New York might have a bunch of different specifications, right? We might want to have extra arguments. We might want to have a different range that we're using for New York subnets. And this could be a good place to store it because that could be common across all the New York modules. It provides you immense amounts of reusability and flexibility. And one of the things that we really like about this is that it allows us to really, really reduce the amount of inputs we're putting into the modules down to the essentials. And everything else should be part of the regional configuration. And that should be your kind of idea of what's canonical. So we've spoken a bit about the Terragrunt HCL. We've spoken about the Terraform config. Now, if we look at the kind of the regional level, you can see that it's pretty simple. You have London 1 and New York 1. And these are just representative Civo regions that I decided would be a good example. In both of these, you have a regional config. These regional config files, all the way down the chain, if you add these files, any sort of HCL with locals, it will get picked up if you poll for it. And I'll show you how to do that. So if you look at the actual module we're trying to deploy, this is convention-based, right? So the convention that I'm using here is that I'm naming the module in Terragrunt the same name as the companion module in the Terraform repo. And so we look at both of these, you can see they're basically the same. They have a Terragrunt HCL file in them and some hidden files. So let's just delete the hidden files and I'll come back to those in a moment. So if we actually look down at the nuts and bolts of what is getting run when we run Terragrunt in New York in Kubernetes module, you can see that effectively it is looking at the Terraform source as defined here from the module catalog. It is looking at the Civo Kubernetes module at a positional tag. It is then inputting these arguments. Equally, you can see if you look at London 1, it's doing the same thing, but it's inputting slightly different arguments. And in fact, I've just got to add one quick line here because that is a really important part of this. This will include all of the Terragrunt files above it. And that's really important for being able to find some of these variable files. And let's have a quick look at what these actually do. So you can see that the first thing you do with any of these locals is you open the file as a variable, and then you can get things from the file variable. So in this in case, I've got the tag of my local tag. I've got the token of the Civo token, because remember, I passed that through to my module, to the Civo provider, and I've got the environment, because that's where I want to set the region. Let's just remind ourselves of why we're doing that. So remember, if we look at the variables, we see we have the region set to New York 1, we have the Civo token as nil, and we have things like a cluster name. And so all we're doing is we're overriding these inputs. Those variables.tf in Terraform will get overridden by Terragrunt. So let's run the example and really start to understand how Terragrunt works. So I'm going to New York, Kubernetes. I'm going to go to Terragrunt plan. What's interesting about the Terragrunt plan is it gives a good example of how this all works. So whilst this is doing something in the background, let's have a look what it's actually doing. Terragrunt will check out a folder called Terragrunt cache. That Terragrunt cache has a UID, a couple levels deep, and then inside of there, you'll see your module that you've tried to pin it to in the remote. But what's really interesting is now I've got an extra file called backend.tf, which I do not have in the remote. And you can do that for any file. You can add any generator step like that. So you could add an entire resource that's generated dynamically. Here, the backend.tf has my token for my Terraform IO account in here. It also has the cluster that I've requested with the variables will be injected. That's done dynamically, but everything else is all set up and ready to go. And so when I go back to Terragrunt, it says, yep, this looks good. So let's give it a roll. Give it a roll, give it a go. So I'm going to do an apply. And whilst it's applying, we'll jump to Civo. We'll see it apply. Oops, it helps if you type yes. And you'll notice that it's the same syntax as Terraform. Okay, so that's now doing an apply. It's already checked out what it needs here to run. It's going to go to Civo. I think are we in New York or London? I think we're in New York. Just refresh my page. And there we go. Terragrunt tests New York, which is kind of cool. So that's all spinning up. And we can see that the cluster is creating. What we can also see is that it's using my remote backend. Another part of this is that we really like using workspaces. Workspaces are really powerful. And you can see that my remote workspace is currently locked because Terragrunt is using it to manage the state. And it's currently locking that from anybody else using it. And this emphasizes what I was talking about with workspaces. So this module is now locked in New York. And if you use a good naming strategy, you can have it so that within every region, within every module, you can have your own workspace. And that provides a huge amount of fidelity on being able to have this micro control over what is being deployed at any one time. Another nice thing about using Terraform IO is it gives the ability to switch between local deployments and remote. There you can run it through the remote runner here. And if you are so inclined and you have a lot of variables and secrets you don't want to keep on your own computer, you can add them within the UX here. I think somewhere there's a button to do so. And it lets you add those variables, and you can then pull the secrets out of the remote. So they'll just be stored in Terraform Cloud, and you can have your team set up here so that only certain folks in the team can then use those variables. So you've got slicing on how the workspaces operate. So you've got security by isolation, you've got security then by authorization, and then of course through the team you have the authentication component as well. So this should almost be done. Let's flick back to our cluster. All of our nodes are up. I think that was a nice little 90-second deployment. Yep, there we go. And I think there's a bit of a delay in Terraform. Oh, there we go. It said it's done.
We have a question that we can answer.
Sure.
So Nas is asking, once you have a reasonably large number of environments across multiple, for example, AWS accounts or whatever, CI/CD becomes a little bit tricky. So they're interested in knowing about how you run automations. For example, do you run Terragrunt only on the change stacks, or do you run it on the entire repository?
It's a really good question, and I'm hoping I can answer it in the next couple of slides, if that's possible. But I'll give you a preview to the answer. Yeah, so it's a good question because you're right. There's a penalty if you're having to plan every environment simultaneously. It has not only a compute cost, it has a time cost as well. We're in the state at the moment where we do plan across about 52 modules or so. But as we would expand to say 20, 100 regions, it becomes impractical because for all the plans to finish and all the applies to finish, even the zero changes, would be a day. So I think really one of the things that needs to be done, or we're working on the moment, is to look at isolating the change. So you actually look at the Terraform change as part of the tag. And there's a few ways of doing this. You can make it part of the tag name, and in the CI/CD, you look at that tag name as the module name in Terraform that's updated, and you can then update that in Terragrunt where appropriate, and actually moving to more of a graph-based approach. But that's a really interesting day two operation, and a good point. And I'll try to show a little bit more about how we do it in a moment. So just in terms of how we've adopted it from what I've just shown you there, which is a very simple example. If you think back to that earlier slide of us using Ansible and Terraform in like 3 different repositories, we've moved to a single configuration repository for Terragrunt and a single Terraform repository. Now, it's not just all Kubernetes and modules. We're also using a bunch of different services and providers in there. The point being that they're all articulated in the same way. And what's quite nice is that with Terragrunt, we have this composable approach that's very easy to iterate on and very easy to work with. So setting up new regions isn't about copy pasting the latest code from dev or from QA or from prod and then changing all the keys. It would be about effectively creating a new folder and then pulling in the modules that you want to work with and setting that up as a new bunch of workspaces. I mentioned earlier that we have workspaces per module. So if you think about this here, you'd have London 1 networking virtualization Civo stack, and that would be completely isolated from the other regions, which makes sense. But what's really nice about that is you can also be running within London with your colleagues who can be running on MISC and observability with zero impact on their work. And it forces you to think about the way that you cut your stack up. And I know that this is probably more towards general Terraform knowledge, but it's really important to visualize it like this because having the separation of concerns and isolating modules in the stack affords you a lot more flexibility and a lot less risk. So we had a question a moment ago about how we've adopted it. So we actually have a large pipeline, as you can see here, where we do a plan and deploy, which is an auto deploy, and then a plan and then a manual gate on the current environment. And it's not an ideal system. That's the first thing, is I'm not representing this to be the Valhalla of how Terragrunt and Terraform work. There are many idiosyncrasies, and as I was just describing, if we had a graph to work out, for example, if somebody changed the networking module, run only the affected Terragrunt modules, that would take us a long way in terms of efficiency and compute. But it's not ultimately saving any other dimension other than efficiency and compute in terms of time compute. So we're willing to pay that penalty for now because we also own all of our infrastructure, so the compute doesn't really cost us very much. And given the size of our digital estate, the time penalty is not so bad. These runs would take about 6 minutes or less. So we've adopted it in a fairly simplistic manner in that we will plan staging. So that would be the entire staging region. So that region would deploy all of its modules simultaneously using the simultaneous commands I showed you earlier. And then it would do a deploy. We could then articulate this again with having a post hook on each one of these, which we don't have yet. And then we can look at doing our production plan and deploy. So there's a lot of room to be desired, but I'm excited because that's a good thing, right? We can see a lot of potential problems that are easy to fix and a lot of gaps that are easy to fix with Terragrunt. So that's really exciting to be in that kind of place. So we have the tools to do it. To give you another insight into how we actually use this from an application deployment point of view, I didn't really talk about this yet, but Civo's based a lot on using Kubernetes operators. So we use Golang-based operators to control how we create our tenant clusters and resources, right? So a K3's cluster gets created as an object in YAML, and an operator will read that object and actually manifest that as virtual machines and as K3's pods. The way that our developers are enabled to push these operators into our production and into our staging environment is that they will work on the code base, they'll run it through their testing, it'll get merged into main, and eventually we'll make at the moment still manual decision to cut a tag. That's a good thing, I think, in a way as well. We can make a decision that is intentional and say, now we want to cut the tag. That tag will then automatically publish to Terraform. And when I say publish, what it does is it will copy over the Helm changes that are required and bump those charts. Because for those of you who have worked with Terraform, there's a good mature Helm plugin, Helm provider. And so it copies the updated Helm charts. It bumps those charts because a double-edged sword of Terraform is that it doesn't always know when Helm is updated. So we increment the app version. Once that's done, Terraform will automatically trigger a new tag. It will automatically trigger a tag saying, hey, I've updated. That tag will be incremented in Terragrunt. So Terragrunt understands there's a new module remote, and that then applies the latest pipeline into staging. So therefore, your operator is into staging and at a click in production in about sort of 11 or 12 minutes. And it's gated by your tags, it's gated by your tests. There's plenty of room for improvement. We could have additional steps, but this has provided so far a pretty robust and stable pipeline, and it's allowed us to help the developers accelerate their delivery. So I've mentioned a few resources. Feel free to grab these. I'm sorry they're only, you can't click through to them, but I'm sure we can share them in the chat later on. If you want to play around with the Terragrunt configuration, the Terraform module catalog, all you need is your own Civo token and your own Terraform workspace. And for bonus points, if you want to try and not use Terraform workspace, try modifying that backend to a local Terraform state. It will work. You just need to change it so that it's not using a remote workspace. And if you want to learn any more about Terraform Cloud and Terragrunt, there's a little bit of information on terraform.io about how Terraform Cloud is a useful component in all of this for remote workspace management. I'll speak a little bit more about that just before I move to the next slide. And the reason that we chose Terraform Cloud over using an object store is not only that it is easier to work with in teams, it's also that we can have very simplified RBAC so that we could have deployers who can roll out to production but can't delete from it. And I personally prefer this rather than adding manual lifecycle hooks into the Terraform module, because that then means you have to decode it to then be able to destroy something. So there are a bunch of benefits, and for anybody who's thinking of dabbling with it, I really recommend it. Had a lot of success. It's been really quite useful for us. And so yeah, that's the end of my webinar. Little plug from Civo here. You can try us out. Please feel free. But if any questions, I'll be happy to answer them in the chat.
We do have quite a few. First of all, thanks a lot for the presentation, Alex. It was amazing. And Elliot is asking, does each Terragrunt or HCL file create its own workspace in the cloud, or is it common workspace for every environment? Yeah, so the way, I mean, this is completely up to you. The way that we do it is that each Terragrunt subfolder in a region has its own workspace, and that is controlled by that module would have a local, like a local environment.hcl. So if my module is called virtualization, or it's called Kubernetes, or it's called storage, it would have a file with a local variable saying, I am storage, or I am virtualization. It then comprises those together, right? So your Terraform IO workspace becomes Civo-London1-virtualization or storage. And so then it gives you a high granularity. So yeah, we have a bunch of workspaces rather than having just one big workspace. I believe that answers the question. Thanks a lot for sharing, Alex. Cool. All right. So Tejas is asking a question. What are the challenges Civo faces while using Terraform, and what can be an alternative to it? It's a really good question. Terraform is a fantastic tool. There are some practical challenges around it. It's quite slow. You know, it's doing a lot of infrastructure changes. There's quite a lot of voodoo around how to do state management. So what I mean is, you know, doing a state move or a state delete or manually importing state. I think that it is documented, but it's not very well understood how these things work to a lot of people. And so there's a bit of a learning curve. And also, you know, some of the things that we have problems with are the providers. So like I mentioned with the Helm provider, you could change your Helm chart completely. Terraform won't pick that up because of the way that Helm works in the provider is that it doesn't recognize the change unless the app version has been incremented. So there are quite a few idiosyncrasies
that are challenging sometimes. And so to overcome that, we've had to build a system where we actually bump the chart version every time. So it's a very nuanced system, but Terraform is very, very powerful. So it's a double-edged sword. You know, the challenge is constantly learning how to work with it whilst also achieving what we want.
And Roman is asking, what about multi-region, multi-environment deployments? Do you have an example of this kind of setup as well?
Yeah, so that's a really interesting one. So like if you want to do multi-cluster, so we're in the infant steps of this. So I can't give you an example because it's not finished yet. But an example of what we could show you eventually would be we're using Thanos for our Prometheus aggregation. And that's a difficult one because if you wanted to set that up multi-cluster, you would have a dependency on different clusters. And so the way I would probably do that is we would have something like a Terragrunt folder called multi-cluster or something like that, inter-cluster, inter-regional. In that, you would then probably have your modules. You might even have a couple of the same module, right? If I want to deploy Prometheus twice to two different clusters, you would have effectively that module twice. But what we've done at Civo, which is quite interesting, is that the Kubernetes config, I didn't really mention too much. In my example, you saw it being pulled out from the cluster. We actually add our Kubernetes config into Terraform so that each regional cluster has its own K8s config there. So what happens is in a Terragrunt HCL, when you build that generate provider, you can just say, hey, look up in my directory, find my kube config, use that. You could do the same thing. So in the Thanos multi-cluster, you can have a kube config for all the clusters you want to use and deploy out your components. So I think actually I do have sort of an example, but I can't unfortunately show it because I've not pulled it together. But yeah, it's completely possible. It's all about how you design your file structure. But the nice thing about it is once you've found a working structure for multi-cluster deployments is that you can add in modules without needing to do a copy paste on the whole thing.
Thanks for sharing, Alex. And Amrit asks, how have you automated these scripts for the end user? How do you manage the scaling or deleting of the cloud resources?
I'm just thinking, would you mind repeating the first part of that question?
So the first part has, the ask is, how have you automated the scripts for the end user?
How have we automated the scripts for the end user? I'm not really sure how to answer. I mean, I guess if you're thinking, how does the automation work in terms of how does Civo build stuff? That you'll have to come to our KubeCon talk for in October. But we heavily use operators. So the end user, so someone who's using the CLI, using the website, all those requests go through and effectively think of it as like a factory where your request is read, it is then split up into other requests, and then it is reconciled. I'm sorry, that probably might not have been the exact answer you want. I just wasn't sure what you were asking. And in regards to scaling, we have auto scaling in terms of our tenant clusters. And this is probably an important concept to understand is we run, as I showed earlier on, extremely large superclusters. And inside of there, our tenants run. And they run in pods. And we can control the constraints on those pods. So when they're running in a VM, it's not like we have to shut down the VM and resize it. It's changing the constraints on that VM, right? So we change the CPU limit to increase it on that pod. I apologize if that wasn't a complete answer, but I'm happy to take it offline and respond a bit more if I can.
Cool. And Lee's asking, I've only started to look at Terraform as Civo offers it. Is there any way to load in YAML files after the creation process?
Yeah, there is. You can use post-execution hook. It's called local exec provider, a local exec provisioner in Terraform. You can do that. And also a really nice pattern as well is if you're thinking about sort of YAML files from Helm, what you could do is I like to create a charts directory in my Terraform repository and have a Terraform a Helm provider, and that Helm provider would run those charts. And if you're making your own charts repository, charts repo, all it is basically a chart.yaml and a templates folder. You can put in all of your Kubernetes manifests, right? They don't need to be special charts. And so if you've got CRDs or if you've got like a Hello World Nginx pod, you can dump it in there and you can create a Helm release resource that applies that. And that Helm release, you can put a depends on, so it only runs after your Civo cluster's installed. So you can create that nice dependency where once the cluster's up and running, Helm will then install any YAML files that I might have. Happy to take, again, some examples from that in our Civo community channel, if you like.
Yep. So you can join the Civo community channel. You can, I'd also like to do a plug over here. You can check out the academy and that you can learn about K8s, and you can join our community Slack, and Alex is there and everyone is there. Be more than happy to answer your questions about your use cases. Cool. Hamza is asking, do you have multi-tenant deployments using Terraform? If yes, how do you store the states for every tenant?
Multi-tenant deployments using Terraform. So actually, I mean, I kind of get what you're saying in terms of tenancy of accounts, like in AWS accounts. So our current model is that we are deploying across our regions. So effectively, we are owning the single tenant in that we own the entire cluster. Now, in terms of tenancy for our customers, we're not using Terraform to deploy. We're actually, as I said, we're using our operators. And so our tenant state is always captured through etcd because they're custom resources, so that if we wiped our cluster and brought it back up, it reads etcd and it reconciles and recreates them and reloads the storage layer in. Again, I feel like I probably missed slightly your question on what you mean by multi-tenant deployments, but happy to take it in the channel. I apologize.
Cool. I see an interesting one. So Zahari is asking how much of the infrastructure as code needs can be defined as Terraform, and what corner cases you know that cannot at the moment.
Would you mind saying that the last half of that question again?
So like how much of the infrastructure as code needs can be defined as Terraform, and which corner cases you think that that cannot be done at the moment?
Yeah, so the stuff we can't do with Terraform is the provisioning of our hardware. So like the L3 stuff, right? Like setting up anything that is part of the networking layer. Also, like provisioning the superclusters themselves is done through Ansible, because we have a set of IP addresses in the hosts file in the inventory. Those are on the range. Those are determined. And so we use Ansible for that. So we kind of compartmentalize it. So when we set a new region up, that's Ansible that will deploy the supercluster to that region. And then everything else effectively is Terraform. And that's because we don't have a provider that can operate at bare metal like that. And yeah, so that's really for us the only real division. Another corner case would be, we're using managed DNS through Terraform. But again, that's an idea. That's a kind of an example of something that's not within our digital estate. But yeah, it's primarily just using when we do the provisioning of bare metal and firewall provisioning on that bare metal as well. So when we're setting up the IP tables, those would typically be done in Ansible as well.
Thanks for sharing, Alex. There's a question. I don't think if it's complete or not, but Oliver is asking process and tools to merge remote states.
Yeah, so it's tricky. I actually quite like the Terraform IO interface because you can do a diff on state. The process of merging remote states is tricky. I would tend to take one state locally, use a backend TF and use that local Terraform state, load that in. Then I would download the remote state into another file, and using Terraform, you can open, you can do from on a state file, and you can read it, right? You can do a list from the state, and I would cherry pick one by one from the second state file into the first. It is difficult, and it again comes back to what I was saying, that Terraform is very deep and it has a lot of idiosyncrasy and voodoo around how to do this. If you've got a particular example, we can jam on it again in the community channel. I'm happy to talk about it. We had to do a lot of this stuff in the early days where we went from a strategy of having like 10 workspaces at the root level, right? But then quite quickly realized that we had to move to having this structured approach of regional and then modular based. So we had to actually move our remote state. And so, yeah, I feel your pain. It can be really difficult.
Thanks for sharing, Alex. Richard is asking, how do you separate out compute and networking, etc.?
Sorry, how do you separate compute?
Compute, network, etc.
Yeah, so again, it depends on what we're talking about here. Like the L3 for so we own our physical racks, right? And a lot of that is set up prior to us actually ever running Ansible or Terraform, right? So this physical infrastructure, when we're talking about things set up on the top of rack and the spine and all of the various physical infrastructure configurations are done outside of this and through, whether it's the micro tick or other things that we're setting up, they're all done prior to this kind of phase. And so I think there is kind of a multi-phase approach in that once that's done, we then do the provisioning of network available on the VLAN, right? Because there'll be a VLAN that's assigned to the rack and on the NIC, on the bonds that are available. And then we will configure the machines on top of that. And then once that's done, we're kind of at the Terraform stage. So once you've then got those machines online. So I guess we're slicing it based on what tooling is available at that particular layer. We are trying to move more in the direction of Terraform for everything, but I don't think it's a panacea, right? Like, I don't think you're ever going to be in that position where you have Terraform to provision even at the switch level. There just simply aren't the providers that are going to be available to communicate over those protocols.
Awesome. Well, I believe those are all the questions that we had, and we answered everything. So thanks a lot for joining us, Alex, and thanks a lot to everyone who has joined the session today. You can find the recording for this on the YouTube channel, and yeah, we'll see you next time. Make sure you check out the YouTube channel as well while we're at it. We have some great content over there, and yeah, have a good day and a good night from where you're joining, and we'll see you in the next one. Bye.
Thank you.